Hey, this is Bill from Tutor Bros. In this video, I want to go over how to find the formula that will sum a finite geometric series. So let's go over an example of what a geometric series is. So let's say we'll call S what we want to sum, the total sum. So we'll set that equal to, and then we'll start with a constant, in this case 1, and then we'll multiply each successive term by another constant that we'll label R. But in this case, let's say R is equal to 2, and then we'll add the next term. So we're multiplying by 2 the term before it, so 2 times 2 is 4, and then we'll add 2 times 4, which is 8, and then for our example, we'll just stop here, and then we'll add these up, and it's equal to 15. So that's pretty easy, but let's say the series was longer, and let's say we just want to come up with a generic formula to help us solve that. So we'll start with S again, and we'll start with 1 again, but this time instead of saying 2, we'll just multiply by a number R, and then we'll add the next number, which is R times the number before it, so R squared, and then plus, and we'll keep adding numbers until we get to some arbitrary number R to the n minus 1. And just a reason why we stop it, n represents the number of terms in the series, and the reason that we stop at R to the n minus 1 is, if we go up to the example above, the first term is actually R to the 0, which is 1. Any number to 0 is 1. And then we'll add R, which is the second term. The third term is R squared, sorry, R to the 1. And then the fourth term is R to the third. So it's the number of terms minus 1 is the last term raised, it's raised to that power. So in this case, it's the third power. So there's 4 terms. So it's 1 less than the number of terms in the series. So that's why we stop at R to the n minus 1. Okay, so now we have our series, and just on this, so for our example up here, I'll write R is equal to 2, and the number of terms here is equal to 4. So for our going back to our generic formula for the series, to help us solve this, we'll actually copy the formula below and multiply both sides by R. So this becomes R times S equals, and then the first term, we're multiplying R times this 1, and we'll multiply the R out. So R times 1 is R, and I'll actually write it one term over, and you'll see why in a second. The next term is R times R, which is R squared, and then we will do plus dot dot dot, and then the term right before the last term in this example is R to the n minus 2. So R to the n minus 2 times R is R to the n minus 1, and then the last term, we're multiplying R times this last term in the line above, and it becomes R to the n. Okay, so the reason why we multiplied R on both sides and copied it down is because we're actually going to take this whole line and negate it and then subtract it from the line above. So the left side of the equation becomes S minus R times S. And then here, if we're negating all these R's and we subtract them from the one above, first we're left with 1, so we'll bring that down. And then all these R's cancel. The R squared cancel, all these in between, and then the second to last here cancels with the last one here, and we're left with minus R to the n. Okay, so now we want to isolate S on the left side and solve for S. So we will factor out S, and this becomes S times R, 1 minus R equals 1 minus R to the n. and then we'll divide 1 minus r on both sides. 1 minus r. So this is actually the generic formula to help you solve for a finite geometric series where you start, the first term is 1, and then you multiply r by every successive term, and then n is the number of terms in the series. So let's go back to our first example and plug in some numbers here. So this is s equals, now remember up here, r is 2 and n equals 4. So we have 1 minus 2 to the 4th all over 1 minus 2. So this becomes 1 minus 16 over negative 1. So negative 15 over negative 1 is 15. And that is the same answer that we got here. So that is how this is the formula we use to help us solve for a geometric series when you're summing a geometric series where r is the number you're multiplying by and n is the number of terms in the series.